Hi dear students, I hope your board exam revisions are going really well. We have few days for the science examination. So in these days, we are coming up with the live revision session, which will be a booster for your revision plans, especially those who have finished the revision once. When we go through this live discussion and questions, it will help in increasing your confidence level and see if you are able to actively recall whatever you have studied in these days. So today we are going to have a quick walkthrough through the chemistry chapters of class 10 science. So before we dive into the discussion, I would like to know if I am clearly audible to each and every one of you. So if yes, please leave a comment in the comment box. Am I audible to everyone? Yes. So I hope I'm loud and clear to each and everyone. Okay, perfect. So we will be moving in the order of the first chapter, chemical equations, then acids, bases, and salts, and then metals and nonmetals, and then carbon and its compounds. So during this discussion, I want your active participation in the discussion, especially when I discuss a particular question and a related concept regarding that. You have to first read the question thoroughly and try to answer it yourself and see how well you can actively recall everything related to that particular content. Okay, so let's move on to the first question. Yes, so you can read the question. In chemistry laboratory, the students added zinc granules in a conical flask and all of them poured a few drops of dilute sulfuric acid into the flask and made the following observations. See, in these kind of lengthy questions, especially when you read the first part of the question, try to recollect everything what you learned about that, so that the remaining sections can be found really easy for you to answer. For example, in this question, they said the student is adding zinc granules and sulfuric acid. So you know that zinc is a metal and sulfuric acid being an acid is going to have a reaction where a displacement reaction takes place and you get zinc sulfate plus hydrogen, correct? So this is the reaction that is going to happen. Now we will read the rest of the question. So we have bubbles of gas are found to rise briskly from the surface of zinc metal. See, reading that statement, it clearly indicates it is a true statement because you can see that one of the product in this reaction is hydrogen gas. So this gas will be liberated. So we will see those bubbles rising from the surface of the metal. Then there is a change in the temperature. See, we have studied a lot of reactions where metal plus acids is reacting to form salt and hydrogen gas. Especially the one which you learned in textbook is the reaction between zinc and hydrochloric acid. And you have seen that, it's pretty much a highly exothermic reaction. It releases a large amount of heat during this reaction. So as a result, definitely you will be observing a change in the temperature. You know that there are two types of reactions in terms of the energetics. One is those reactions which liberate heat energy, which is called as exothermic reaction, and the other one is those which absorbs energy during the reaction, which is called endothermic reaction. Right. Now, look at the next statement. A yellow colored solution is formed. See, here the solution formed is zinc sulfate. Zinc sulfate aqueous solution is basically colorless. It doesn't have any characteristic color, right? Then the color of the gas formed is brown. See, you can see that the gas formed in this case is hydrogen gas. Hydrogen gas doesn't have any characteristic color. So the question is, which of the above observations are correct? Yes, we can see that the statement 1 and statement 2 are the only true statements. The statement 3 and 4 are wrong. So I believe all of you were able to answer this question very easily. So let me see how many of you got correct answers. All of you were able to do this, right? Okay, perfect. So the take from this particular question is you have to recollect what happens when metal react with acids. Metals are generally basic, except some few amphoteric metals are there where zinc, aluminum, gallium, these kind of metals can react with acids as well as bases, right? Okay. So let's move on to the next question. Okay, here is the question. The green color of metal salt A first changes to white solid B on heating. On further heating, white solid B turns into a brownish black substance. C. Which of the following option gives the correct information about the substances and the type of the reaction involved? So in this question, you can see in the table, there are few salts given. We have lead nitrate .7H2O, we have CuSO4.5H2O, FeSO4.7H2O, FeSO4.5H2O. See, from the starting of the question itself, it is very evident that it says the green color of metal salt changes into white. And you have studied one of the most important green colored salt whose thermal decomposition reaction was covered, right? Which is that salt? It is ferrous sulfate. So we have ferrous sulfate heptahydrate, FeSO4.7H2O. This will be the green colored salt. And you know that when you heat a hydrated salt, the water of crystallization will vaporize. So all the water will be gone and you will have only FeSO4 left, right? And this FeSO4 is a white colored substance. And you know that if you continue heating this FeSO4, what is going to happen? If you continue heating FeSO4, this is going to thermally decompose, right? And what do you get? You get Fe2O3 plus two gases, that is sulfur dioxide and sulfur trioxide. These two are non-metallic oxides, and it's pretty much acidic oxide, right? It's an oxide of sulfur. So here is the this is the hint from that question. So green colored salt is FeSO4.7H2O, and it changes into a white solid FeSO4 because FeSO4 is colorless. And then we have the on heating it changes into brownish black, and that's going to be Fe2O3, and it is a perfect example of thermal decomposition. And you have studied two more additional thermal decomposition examples, right? In chapter 1. One is decomposition of lead nitrate, which forms lead oxide and nitrogen dioxide and oxygen gas. And also apart from that, you have studied the thermal decomposition of calcium carbonate, which is going to give you calcium oxide, which is quicklime, and carbon dioxide. So three thermal decomposition examples you have studied in this chapter. So any one of them will be definitely coming for the exam. So please do remember and recollect all the observations of those three thermal decompositions. Hope this question is clear to everyone. So we will have the correct answer as option C. Right, great. Now let's move on to the next question. On heating a blue colored powder of copper nitrate in a boiling tube, a black substance X, oxygen gas, and a brown gas Y was formed. Select the option which identify the products correctly. See, here they say they are heating copper nitrate. So copper nitrate is having the formula CuNO3 twice. And this copper nitrate on heating, it produces a black substance, oxygen gas, and a brown gas. So this is very much similar to the thermal decomposition of lead nitrate, correct? So what do you get when you heat lead nitrate? You get lead oxide, which is yellow in color. You get nitrogen dioxide, which is brown colored fumes, right? And then oxygen gas. So the same is going to happen here. Instead of getting lead oxide, here you are going to get the oxide of copper, right? And you have studied that the color of oxide of copper is black. So that is going to form plus nitrogen dioxide plus oxygen gas. So the brown fumes what you observe in this case is going to be NO2. So we got everything about that particular reaction. Now let's see which is the correct option that identify the product correctly. So here you see the black substance formed. That is, I already told you it is copper oxide. And then what is the brown gas Y formed? Brown gas Y formed is NO2. What is NO2? NO2 is nitrogen dioxide, isn't it? Nitrogen is an element that can combine with oxygen in various proportions. There are so many different types of oxides like N2O, dinitrogen monoxide. We have NO, nitrogen oxide or nitrogen monoxide. We have N2O5, N2O3, N2O4. There are plenty of oxides of nitrogen. So in this case, we are going to get nitrogen dioxide, which is brown in color, right? So the correct option will be the black substance is copper oxide, and the brown gas is going to be nitrogen dioxide, right? So that is also clear to everyone. See, as we move through these questions, we are actually covering the entire syllabus and the most important areas. So those who have completed one-time revision will be finding it really easy, and it will definitely boost your confidence that, you know, yes, I am able to recollect whatever I have studied. And those who have not completed, stay with me, listen carefully, and try to learn all these important points which I am explaining during this session. Okay, let's go to the next question. Yeah. A student poured 100 ml of water in a bottle and added 40 ml of vinegar to it. A balloon was filled with 20 gram of baking soda and was fixed at the mouth of the bottle. Slowly, the shape of the balloon changed as shown. The student claims that a chemical change happened when the two substances were mixed. Is the claim made by the student correct? See, before we jump into the options, let us try to recollect what is happening in that particular process. They said a student poured 100 ml of water in a bottle and added vinegar into it. So we have acetic acid solution with us, and now to that we are adding baking soda. So you know the reaction between acetic acid and baking soda. It's a very, very important reaction. CH3COOH is the formula of acetic acid, and it's going to react with NaHCO3. When I write this down, you have to actively recall all the important chemical properties that you learned when you studied acids, bases, and salts, right? You have studied that acids are going to react with metal carbonates and metal bicarbonates to form salt, water, and carbon dioxide, correct? So this is also a similar example. We have acetic acid with us, it is an acid. Then NaHCO3, which is a metal bicarbonate, sodium bicarbonate, or sodium hydrogen carbonate, or baking soda. Commercially, this is known as baking soda. So this substance is going to react with acid to form the salt CH3COONA plus H2O plus CO2. So here we have a salt obtained. That salt is sodium acetate or sodium ethanoate, correct? Sodium acetate or sodium ethanoate. That is a salt formed in this reaction. Right. Now, they said the student claimed that a chemical change has happened when the two substances were mixed. Is the claim made by the student correct? See, you have studied that whenever a chemical change happens, there are a lot of signs. So let us go through these options and see what is the best fit choice for this particular statement. So option A says, yes, as a new substance was formed in the form of a gas. See, that is pretty much true, because in a chemical reaction, you know that every time when a chemical reaction happens, the reactants is changing into products, and you know that the chemical integrity of the reactants is completely gone. Before the reaction, we have CH3COOH and NaHCO3. They are two different compounds. But after the reaction, you are having CH3CONA and CO2 and H2O. They are completely different. So since there is a change in the chemical integrity of the reacting species, we can say that it is a chemical change. Okay, let's read the other options also. Yes, as the mass remains the same throughout the experiment. See, law of conservation of mass holds true for a chemical change. There is no problem in that. But you do know that even in a physical change also, sometimes the mass can be conserved. For example, in a closed container, if you are heating ice, you will see that there is a physical conversion of ice into water, and there also there is no change in the mass. So that claim cannot be an accurate description of why it is a chemical change. No, as the formation of bubbles in the mixture shows a physical change. That is wrong. This is not a physical change. No, as the change in the shape and size of the balloon shows a physical change. Again, that is not an accurate description. So what is the best description that we can pick to claim that it is a chemical change? Because a new substance is formed in the course of every chemical change in nature, right? Excellent. So I think few of you have answered it correctly. Great. So let's move on to the next question. Chemistry teacher writes the following two reactions on the smartboard. CaOH twice plus CO2 gives CaCO3 plus H2O. AgCl decomposes to form Ag plus Cl2. So there are two reactions given here. One is slaked lime coming in contact with carbon dioxide. One is decomposition of silver chloride. After a brainstorming session, the people replied that out of these chemical reactions, one is a combination reaction, two is a decomposition reaction. That is pretty much true. Here calcium hydroxide is combining with carbon dioxide. Here AgCl is decomposing to silver and chlorine. Now she wants to know which class of chemical substance is the product of a decomposition reaction but not a product of a combination reaction. Help her to identify. This is a very basic question but a very important question which need to have a proper conceptual understanding. You know that in a combination reaction it's always combining of two things. It could be an element plus a compound, an element plus an element, a compound plus another compound. But you know that in a combination reaction, since it is always combining, there is no chance that you are going to see an element in the product side, isn't it? So that is the easiest way to identify that it is a combination reaction. So in a combination reaction, an element can never be the product. Is it clear to everyone? I hope that idea is clear to everyone. Yes, some of you have made mistakes in that. Please do understand the concept. So I believe I'm clear. The explanation is clear to everyone. So an element will never be a part of a combination reactions product. But in decomposition, you can see that it may sometimes end up in getting a particular element in the product side. Okay, great. Great. Good, guys, good. Okay, now let's move on to the next question. So an assertion reason question. When copper oxide is added to dilute hydrochloric acid, the color of the solution becomes blue-green. So before we judge whether the assertion is correct or not, let's try to recollect for the reaction that we have studied or the topic that we have studied relating to this. So when copper oxide is added to dilute hydrochloric acid, copper oxide is CuO and hydrochloric acid is HCl, and you have studied that a non-metallic oxide is basic in nature and hence it can react with an acid. So the non-metallic oxide, copper oxide, can react with HCl and it is going to give you CuCl2 plus H2O. Salt and water will be obtained. And what is the color of the aqueous solution of CuCl2? It is bluish green in nature. So the assertion says when copper oxide is added to dilute hydrochloric acid, the color of the solution becomes blue-green. That assertion statement is true. And the reason given, blue-green color of the solution is due to the formation of copper 2 chloride. Yes, that is correct. The reason why blue-green color has appeared is because of the formation of copper 2 chloride. So assertion and reason, they both are correct, and the reason very well explains the assertion statement. So in this case, it's a direct dependency. So we can say that it will be option A. Right. Is that question clear to you? So that's also another important reaction. You can expect this particular question in this coming board examination. It's a very important topic. Okay, let's move on to the next question. The assertion statement says, the reaction of calcium oxide with water to produce slaked lime, releasing a large amount of heat, is a combination reaction. Yes, what is calcium oxide? It is CaO, and it reacts with water to form slaked lime. What is slaked lime? CaOH twice. This is one of the first reactions that we learned in the first chapter, right? It is the combination reaction of quicklime with water to form slaked lime. This process is known as slaking of lime, and this mixture is known as lime water, and we get to see that there is a paste of calcium hydroxide formed at the end of the reaction, and this reaction releases a large amount of heat as well. So it is a combination reaction and it is an exothermic reaction. So the statement A is correct. the reaction of calcium oxide with water to produce slake lime, releasing a large amount of heat is a combination reaction. Okay, perfect. So let's go to the reason statement. Double displacement reactions are the reactions in which there is exchange of ions between the reactants. Correct? Double displacement reactions are mutual exchange of ions, isn't it? So we have seen so many types of double displacement reactions. Say for example, barium chloride plus sodium sulfate. We see that it's going to give you barium sulfate plus sodium chloride. This is also, this is a double displacement reaction, and this is a precipitation reaction. In this reaction, we see that there is formation of an insoluble precipitate of barium sulfate, which is white in color. So it is a double displacement reaction because there is mutual exchange of ions taking place. So the reason statement is also correct. But do you think, is there any direct relationship with the assertion statement? No. They are two independent statements, so we can go ahead with the option B. Right. Okay, great, great. Most of you have answered it. Very good, very good. Keep it up. Okay. The next question. A whitewashed wall develops a coating of calcium carbonate after a few days. See, a whitewashed wall develops a coating of calcium carbonate after a few days. You know the principle of whitewashing. I would say it's pretty much continuation of this particular reaction what we discussed previously. In whitewashing, we are going to apply a paste of calcium hydroxide on the walls. And when it comes in contact with carbon dioxide in the atmosphere, what will happen? There will be a reaction to form CaCO3 and H2O. This H2O will get dry eventually and leaving only calcium carbonate. Calcium carbonate is the one which is giving shiny appearance to the walls, and you know that this compound is also known as limestone. This is the principle of, yes, this is the principle of the whitewashing. So the statement what they said in the assertion is correct. It develops a coating of calcium carbonate after few days. That's true. The reason given, calcium hydroxide on the wall reacts slowly with carbon dioxide in the air. Indeed, that is the reason why it develops a coating of calcium carbonate after few days, because of the reaction between calcium hydroxide and carbon dioxide. So we can say that they both are dependent statements. So the assertion and the reason are dependent to each other. So we can go ahead with the option A. Yes. Yes, Kirtan, very good. Excellent. Yes, Devang, really good. Keep it up, guys. Keep answering like this. Then only, you know, it will boost your confidence and you will feel that, you know, you are ready for the end game. Right. The next one is a case-based question. A piece of magnesium ribbon is added to a flask containing dilute hydrochloric acid. Hydrogen gas is formed, which is collected in the measuring cylinder. The amount of hydrogen formed with time is plotted on a graph. The line on the graph indicates the rate of chemical reaction occurring in the flask. So here we have magnesium ribbon added to an acid. So we have already discussed about this. When a metal is added to, especially a reactive metal like magnesium is added to acids, it is going to show a displacement reaction where you will see magnesium chloride and hydrogen gas will be formed as per the chemical equation which I am writing here. Mg plus HCl is going to give you MgCl2 plus H2. Now what they did is they plotted a graph of volume of hydrogen liberated versus time. So basically this is like measuring the speed of the reaction, like how fast is the reaction or how fast hydrogen gas is produced in over the course of time. That is what they are going to find out. So the question here is, at what time is the reaction rate fastest in the flask, at the start or at the end? See, in order to understand that, let's analyze this graph. So here is the starting of the graph and here is the ending of the graph. Here it very well tells us that volume of hydrogen produced. You see, at the 0th time, this much is the volume. After a few minutes, this much is the volume. After a few minutes, you can see that initially when the amount of hydrogen gas formed is increasing dramatically, right? But towards the end, what do you see? You see a flat line here. What does this flat line indicates? Even if the time is moving ahead, still there is no change in the volume of hydrogen. That means the reaction is sluggish towards the end, but it is fastest in the initial time period. So that is the assumption that we have to get from this particular graph. So we can say clearly that the reaction is fastest in the beginning or at the start. Is that clear to everyone? I hope the ideology or the concept behind this question is very clear. I can see that some of you are saying it is fastest in the end. No, the reaction's rate, the speed of the reaction is measured by looking at how much product is formed in how much time, or how much reactant is consumed in how much time. That is how we measure the rate of a reaction. When you reach in 11th, 12th grade, at that time there is an entirely a complete chapter dedicated for studying this rate of the reaction. It's called chemical kinetics. So those who are going to take science will see this coming up in your higher classes. Right. So which of these could increase the rate of the reaction in the flask? What are the methods by which we can increase the rate of the reaction in the flask? See, adding more acid to the flask. See, if you increase the acid concentration, definitely the rate of the reaction will increase. Heating the acid in the flask, definitely. Temperature plays a very important role. You know that there is a theory related to the temperature dependency of reaction speed. It is said that if you increase the temperature by 10 degrees Celsius, the rate of the reaction will get almost doubled. This is actually again a concept in 12th grade. It's called as Arrhenius equation. So at that time you will learn in detail, but in short, I'll tell you something. If you increase the temperature, you can imagine that the kinetic energy of the reactant molecules will increase. So if the kinetic energy increases, they will collide faster. So that will bring out more and more reactions in shorter period of time. That's the simple logic, right? So hope you understood that clearly. Right. And the third option says using a higher concentration of acid. Definitely more concentration of acid will have more H plus ions. So definitely the rate of the reaction will increase. So we can say all these three is going to increase the rate of the reaction. Now we have one more part in that question. Let's read that part. The reaction is repeated with magnesium powder in place of magnesium ribbon under the same conditions. Will the reaction rate increase or decrease? That's a very important question, guys. You should remember that the rate of the reaction also depends on how much surface is exposed. For example, powdered metals have more surface area compared to an entire piece of metal. So if you powder a metal and add it into an acid, that will have more violent reactions than a metal block being directly added into water. Is that clear? And what is the reason behind this? Powdered metals are having greater surface area. So more the surface area, more faster will be the reactions. So I hope you understood all these things related to the rate of the reaction. So in case-based questions, one of the most prominent area where they could ask a question is like this kind of question. So please do remember, you have to explain your answer with reference to the volume of hydrogen formed in the flask at 2 minutes. So you have to say that powdered metals are having more surface area. So higher the surface area, faster will be the rate of the reaction, or faster will be the volume of the hydrogen produced in this particular case. Okay? Right. So that case-based question is pretty much clear to each and every one of you. Yes, if it is clear, can you confirm it? I'm waiting for that. Everybody understood this? Okay, okay, right. So let's move on to our next question. X, Y, and Z are three elements which undergo chemical reactions in the following way. X2O3 plus 2Y gives Y2O3 plus 2X. ZSO4 plus Y gives Y2SO4 thrice plus Z. ZO plus X gives X2O3 plus Z. Based on the above chemical reaction, answer the following questions. Guys, one of the most important question which you can expect from chemical reactions chapter is predicting the reactivities of the metals based on experimental data. See, since nowadays CBSE is more focusing on competency based questions, you have to understand that they will never ask you a question like zinc and copper sulfate is reacting to form zinc sulfate plus copper. What is the reason? Zinc is more reactive than copper. No, don't expect such kind of direct questions. They will give you case scenarios like this, and they will ask you who is more reactive, who is less reactive, who is moderately reactive, and all. And that can be easily understandable if you know the logic behind this. You can see that in this first reaction, X2O3 plus 2Y gives Y2O3 plus X. By looking at this reaction, we see that Y is able to displace X from its compound, correct? And it forms Y2O3 plus 2X. That means Y is an element who is more reactive than X. So immediately we can conclude that Y is a more reactive element than X because Y is able to displace X from its compound. Then the next reaction says ZSO4 plus Y gives Y2SO4 plus Z. So in this reaction, what is the inference? Y is able to displace Z as well. So you can see among X, Y and Z, Y is able to displace X as well as Z. So you got the answer already. What is the most reactive? Which is the most reactive element? The most reactive element will be Y because it is able to displace both X and Z from their compounds. Correct? So the most reactive element is going to be Y. And then ZO plus X gives X2O3 plus Z. So from the last reaction, it is very evident that X is able to displace Z, which means X is more reactive than Z, right? X is more reactive than Z. So we already found that Y is most reactive. So we can say that if X is able to displace Z, definitely Y will be able to displace Z because Y is able to displace X and that X is able to displace Z. That means Y will be able to displace Z. So what will be the least reactive element? The least reactive element will be Z. So if they ask you to arrange them based on the order of their reactivity, we can say Y will be most reactive, then X, then Z. It's very simple. All you need is this conceptual understanding that if you get a single displacement reaction, what is the inference from that? If the reaction happens, then whoever is displacing will be more reactive than the one who is getting displaced. If it doesn't happen, it's the other way around. Hope it is clear. Okay, perfect. So I think this question is also clear. Now, see, this discussion is going to ease your preparations to a great extent, and trust me, you are going to have your confidence level this high after this session because you will be covering the most important probable areas where a question can be asked in board exam. So you will be more focused in terms of your revision rather than reading NCERT textbook again and again and searching through various sources of reference materials for doing a lot of questions. So stick to this plan. Revise. You already have revised the topics for your pre-board examinations in school and the model examinations which we conducted in our center. So you already have a good amount of confidence. So to boost that and to make you focused into this these 3 days of time, this session is introduced. So I believe everyone is following up all the instructions which I am giving, and all of you are able to understand what I am explaining. Right. Now, can we get this PDF? Yes, definitely, guys. We will be sharing this PDF in your respective WhatsApp groups. So if anybody has not got the PDF, please do text our office and they will send you. Okay. After this session, we will be sending this in the respective WhatsApp group. Okay. 8 identical iron blocks are placed on the ground in the 2 arrangements X and Y as shown below. The block arrangements are kept moist by sprinkling water every few hours. The question is, which of the arrangement is likely to gather more rust after 10 days? Justify your answer. Justify your answer. Yes. So here you can see there is a block X and there is a block Y. And they said these are placed in the ground in the 2 arrangements. The block arrangements are kept moist by sprinkling water every few hours. So water is being sprinkled on it, and they are in contact with air. So definitely both the cases will have rusting developing on it. The question is, which of the arrangement is likely to gather more rust after 10 days? Justify your answer. See, here you can see that in both the cases water is available for both of them, but oxygen is also one of the factor that is going to play an important role in corrosion. You guys know that corrosion is the phenomenon in which heavy metals like iron will react with oxygen and water to form Fe2O3.XH2O. This is called as rust. So in order to have rusting, you know, both these factors are essential. It's not either of them. You need both of them, oxygen and water. And more surface is exposed towards these agents, more will be the rate of rusting. So here you can see that most exposed surfaces is for Y, but X is kept like this. So what happens is the below surface is not in contact with air. But in case of Y, the surface which is concealed from air is only this much, but the other surface is completely exposed to air and water. So who will have more amount of rust formed? Definitely the block Y will be having more rusting, because it has more amount of surface exposed towards the outside. So definitely rusting depends on all these factors. The metal has to be exposed to both the agents, that is oxygen as well as water. Right. So the first part is clear. Now let's read the next part. The following chemical equation does not represent a chemical reaction that can take place. Fe plus 4H2O gives Fe3O4. State what need to be changed in the equation above for it to represent the correct equation between Fe and H2O. See, you know that iron is an element which is not as much reactive as alkali metals or alkaline earth metals, correct? So it needs steam to react with iron and form the corresponding oxide plus hydrogen. So you need to complete this reaction by adding the missing component. What is the missing component? The missing component is hydrogen gas. So what is the take from this reaction? The take from this reaction is metals react with water to form metal hydroxide or metal oxide plus hydrogen gas, right? You remember that chemical property, and you have studied which all metals are going to react with cold water, which is going to react with hot water, which is going to react with steam, which is not going to react. So do revise all the examples that you have learned with respect to the reaction with water. So highly reactive metals like alkali metals and alkaline earth metals, they are going to react with water to form bases like hydroxides. Whereas moderately reactive ones like iron, aluminium, zinc, etc., they will form the corresponding oxides plus hydrogen gas. Okay, is this clear to everyone? Right. Now, what happens when a solution of potassium iodide is added to a solution of lead nitrate? See, in the double displacement reaction or the precipitation reaction, one of the most important experiment that you learned in the textbook is this reaction. What is potassium iodide? Potassium iodide is Ki. So if you take an aqueous solution of Ki and mix it with lead nitrate, what is lead nitrate? Lead nitrate is PbNO3 twice. So this is also an aqueous solution. So when aqueous solution of lead nitrate and potassium iodide is mixed, what will happen? You will see a double displacement reaction happening, and you will see that lead iodide is formed along with the KNO3. Lead iodide is formed along with the KNO3. Lead iodide is a yellow colored precipitate. So this is going to get precipitated at the end, and potassium nitrate is a aqueous solution which is colorless. So the observation of this reaction is the formation of yellow colored precipitate of lead iodide, and it is a double displacement reaction. So this is a balanced chemical equation, and it is a double displacement reaction. Also, you know, you can mention double displacement reaction, and it is also a precipitation reaction, because at the end of the reaction you are seeing the formation of yellow colored precipitate. Yellow colored precipitate is also formed. Clear? So you see, through these questions what we discussed till now, we have actually touched almost all the areas in that chapter, all the important reactions. So more are coming. So by the time we finish this chemical equations chapter, you will be done with almost 90% revision of that chapter. Okay, let's move on to the next question. A silver article generally turns black when kept in the open for a few days. The article, when rubbed with toothpaste, again starts shining. Why do silver articles turn black when kept in the open for a few days? And name the phenomenon involved. I would say the frequency of this particular question is very high. When you look into the past 5-6 years papers, you can see the tarnishing of silver is a frequently asked question in many of the sets, in foreign as well as in India. So this particular process is tarnishing of silver. You know that when silver is exposed to air which contain hydrogen sulfide, it results in formation of Ag2S. Ag2S is silver sulfide. Silver sulfide. Silver sulfide is black in color, and that's the reason why the silver ornaments turns black when you expose them into air that contains hydrogen sulfide. Is it clear to everyone? So the first part of the question asks, why do silver articles turn black when kept in open for a few days? Name the phenomenon involved. So here, this is the reason. Formation of Ag2S is the reason why it turns black. The phenomenon is called as tarnishing of silver. Tarnishing, or it is a kind of corrosion of silver. So this is the phenomenon that happens during the tarnishing process. Yes, excellent. Many of you are answering it. I'm glad to see that. It's a very important question. You can expect this question in any of the sections in the coming board exam. Name the black substance formed and give its chemical formula. We already did that. It's called as silver sulfide and its chemical formula is Ag2S. Ag2S. Okay, so hope that question is also clear. Right. Perfect. Okay, now let's look into the next question. Probably this question most of you might have done because it's there in the sample paper. So PbNO3 twice plus Ki gives PbI2x plus KNO3y. We have to write what is x and y in each of the cases. So look at the first reaction. The first reaction, guys, is lead nitrate and potassium iodide, which we just discussed, right? 2 slides back, we have discussed this. It forms lead iodide plus KNO3. What is the state of lead iodide? That is what is indicated as X here, right? So what is the state of X? X is a precipitate. So precipitate is an insoluble mass. Since it is an insoluble mass, we will write it as S, right? Solid. And what will be the state of KNO3? KNO3 is soluble in water, so it will be aqueous. So we'll write AQ along with KNO3. Okay, so that is also clear. Then we have the second question, which is copper plus silver nitrate gives copper nitrate plus X. So here X refers to the product, one of the product, right? So in this reaction, what you see is copper is displacing silver from silver nitrate, right? Because copper is definitely going to displace silver as it is more reactive than silver. So you are going to see copper nitrate plus who will be this? It will be the displaced silver. So Ag, and you know, since it is written X, you should write the proper stoichiometric value also. So it will be 2Ag because it's a balanced equation which is already given. So don't forget to put the 2. Don't just write Ag, it is 2Ag. The stoichiometry also need to be indicated. Okay? Yes. Now see, zinc plus H2SO4 gives zinc sulfate plus H2. Here again we discussed this reaction in the first slide. Zinc sulfate is aqueous, hydrogen is a gas. So we can say X is going to be AQ and Y is going to be gas, which is G. And then we have D, which is calcium carbonate breaking down into calcium oxide and carbon dioxide. And this is a perfect example of thermal decomposition. You guys remember I told you that there are 3 important thermal decompositions in that chapter. One of them is thermal decomposition of limestone, which is CaCO3, and it is written above the arrow that there is something called X. You know that in all thermal decomposition, what should be supplied? Yes, heat should be supplied. Any decomposition that takes place in the presence of heat is called thermal decomposition, which takes place in the presence of electricity is called electrolytic decomposition, and that takes place in presence of light is called as photolytic decomposition. Okay, great. Now, we have the Next question, which is, yeah, a salt P is prepared by using sodium chloride as one of the raw materials. It is also used in soda acid fire extinguishers. And to neutralize an acid, from the given information, select the incorrect statement. Okay, see, I told you, by reading from the first part itself, you will get to know what is coming up. A salt P is prepared by using sodium chloride as one of the raw materials. It is also used in soda acid fire extinguishers. That's enough. That sentence is enough to identify which is the salt, right? Soda acid fire extinguishers uses NaHCO3. Baking soda is the component used in soda acid fire extinguishers. So the salt P, which is prepared from sodium chloride, is NaHCO3. You guys remember the preparation of NaHCO3, right? So by Solvay process, we can prepare NaHCO3. What was the method, guys? You remember? What is the reaction? We have sodium chloride plus water, which is brine solution, and brine is saturated with ammonia and carbon dioxide. And what are we going to get? We get NaHCO3 plus ammonium chloride. This process is Solvay process, which is used in the preparation of NaHCO3. So the salt which is used in soda acid fire extinguishers is NaHCO3. And from the given information, select the incorrect statement. That's going to be very easy because you know everything about NaHCO3. Let's read. Salt P is sodium hydrogen carbonate baking soda. That is a correct statement. They are asking us to find the incorrect statement. So it is baking soda. Salt P is a non-corrosive base. Very much true. So it's not a strong base, it's a mild base. That's the reason why it is even used as an antacid, isn't it? To get relief from acidity or gastric burns, we use antacids. So one of the most commonly used antacid is NaHCO3. So that is also correct. Then the pH of the salt P is less than 7. Is that true? Less than 7? No, because you know that NaHCO3 is formed by the combination of a strong base, sodium hydroxide, and a weak acid, carbonic acid. So the combination of this is always going to result in a basic salt. And if it is a basic salt, you guys know that the pH has to be greater than 7. It shouldn't be less than 7, right? Less than 7 means it should be acidic. No, NaHCO3 is going to be basic, so its pH has to be more than 7. So this is incorrect. It should be a basic salt. Now let's read the last option as well. The aqueous solution of one of the raw materials, sodium chlorine, is also called brine solution. Sodium chloride, okay, is also called brine solution. That's true. Aqueous solution of one of the raw material. One of the raw material is sodium chloride only for the preparation of NaHCO3. I already showed you the reaction on the top, NaCl plus H2O. That aqueous solution is called as brine. So that is also correct. So the only wrong statement is C. See, MCQs, in MCQ section, you know, you need to read really well and try not to spend too much time on that. Of course, you have to read it thoroughly. One time reading, make it count. Like, you know, you should not be in a position where you read the question again and again and again and waste a lot of time on this particular MCQ type of question. So read it once, focus, and then try to actively recall what you learned related to that subject or that particular chapter. Okay? Right. So let's go to the next slide. An aqueous solution turns blue litmus solution red. Excess solution of which solution would reverse the change? Identify the solution. Again, a very easy question, a conceptual question. An aqueous solution turns blue litmus solution red. Who turns blue litmus red? Blue litmus is turned into red by acids. So excess solution of which of the following would reverse the change? You know that if you want to reverse the change, you need to make it basic. So if an acid is there and you want to reverse it, you need to add a base, right? So our objective is, of the 4 options given here, find which is a base. Sodium chloride. What is its nature? Sodium chloride is a neutral salt, right? Then we have sodium hydroxide, that is a base. Hydrochloric acid, that's an acid. Ammonium chloride. Ammonium chloride is a acidic salt. So I will just mention each of them here. This is a neutral salt, so adding that will not do anything. This is a strong base. Hydrochloric acid is an acid. And ammonium chloride is a acidic salt. So here, if you want to reverse the change, what you have to do, since the aqueous solution is acidic, you have to add a base into it. So option will be sodium hydroxide, which is a base. Right, perfect, guys. I want to add one more point in this question, which is, do all of you know how to find from which acid and base a salt comes from? That is a very, very important area. I will explain that with reference to the last salt given here, ammonium chloride, NH4Cl. If they ask you, find what is the nature of ammonium chloride, what you have to do first is, look at this, guys. Every salt will have a cation and anion. The cation here is NH4 plus and the anion here is Cl minus, right? So what you do next is, to the cation you add OH minus and to the anion you add H plus. So this combination is going to give you HCl, this combination is going to give you NH4OH. That's the easiest way to find. Now you know that ammonium hydroxide NH4OH is a weak base and HCl is a strong acid. So what will be the combination of strong acid and weak base? Strong acid and weak base is always going to form an acidic salt. An acidic salt. So this is the take from this particular slide. Remember the different types of salts that you get when you combine different types of acids and bases. Okay, let me just give a quick recap of that once again. So strong acid, strong base will be neutral salt. Strong base plus weak acid will be basic salt. Strong acid plus weak base is going to be acidic salt. Can you comment what will be the combination of weak acid and weak base? Weak acid and weak base. Yes, guys, come on, come on. I'm waiting. Weak acid and weak base. What kind of salt will be obtained? None? What do you mean by that? None. Neutral? Okay, one is saying, few are saying neutral, neutral, neutral. Oh, I see majority of you are saying neutral. Almost all. Okay, everyone is saying neutral, neutral, neutral. Guys, weak acid and weak base can form neutral salt or acidic salt or basic salt depending on who is weaker among the weak base and weak acid. Because a weak acid and a weak base may not have the same weakness. For example, a base is dissociating 20%, an acid is dissociating 30%. We say that they are weak base and weak acid. But you know, since the acid is dissociating a little more than that of the base, then that combination will give you a salt which is acidic. But what if it is the other way? The acid is dissociating 30%, the base is dissociating 40%. So who will be more strong there? The base is strong, so the salt will be basic. And if the dissociation percentage of both of them are equal, then only you will get a neutral salt. Is that clear? Yes. So just remember, a weak acid, weak base combination can give you neutral salt, acidic salt or basic salt. Any of those three can be obtained. Again, the detailed aspects of that you will be studying in 11th grade in a chapter called Chemical Equilibrium. In that there is a portion called Ionic Equilibrium where you will be learning a lot about salts, how do they behave in water, how do you measure their pH and all those things. Okay, so I believe this idea is clear to everyone. Yes, great. Let's move on to the next question, guys. A student makes an arrangement to test the electrical conductivity of distilled water as shown. The student observes that the bulb does not glow. What could be the reason for the bulb to not glow? So you can see the apparatus there. There is something wrong with that apparatus. Why the bulb doesn't glow? This slide is another concept. This question is another concept. A very important concept that will cover the at least one page of NCERT textbook. That's how you have to do revision now. This is called smart revision. You have to spend less time and cover as much concepts as possible instead of simply do the rote learning process again and again. Yes, look at the apparatus. Here what they have taken is distilled water, right? Distilled water. So you know that no substance in their pure states, especially pure acids, pure bases, water in its purest form, they don't have ions. Since they don't have ions, they don't meet the prerequisite for conduction of electric current, correct? Current will flow only if there is free electrons or free ions. Neither of this or neither of them are present in this apparatus because we have distilled water. Distilled water do not ionize. So since they don't have ions, we do not see any conductivity in this case. So what is the best choice for that? Yes, the distilled water does not have ions present in it. So what is the take from this? Pure substances do not conduct electricity. So there can be a lot of questions based on that single idea. For example, they ask you, does dry HCl changes the color of litmus paper? No. Dry HCl cannot change the color of litmus paper because dry HCl do not ionize, isn't it? Dry HCl do not ionize. HCl don't have ions. So as long as you don't have any H plus ions, you don't see any reaction with the litmus chemical, isn't it? So wet litmus will change the color of HCl gas. When you bring a blue litmus, which is wet, then it will show the color change. Otherwise, no. So pure acids don't conduct electricity. Pure bases don't conduct electricity. Distilled water also don't conduct electricity. Guys, graphite is a very good conductor of electricity. Being a non-metal, since it has free electrons because of its special layered organization, graphite is a very good conductor of electricity. Okay, so that's not the reason. It is the problem with water, distilled water. You add a few drops of acid or base into it, the bulb will glow because ions will be furnished in this. Clear? Okay, great. Which of these graphs show how the pH of the milk changes as it forms curd? You know, curdling process is a biochemical phenomenon, right? What happens is in milk there is a sugar called lactose. So this lactose is converted into lactic acid with the presence of certain bacteria called lactobacillus. This lactic acid, being an acid, will affect the structure of the proteins present in milk, and that causes something called coagulation or denaturation of the proteins. And this denaturation of the proteins will cause all the proteins to clump together and they form a solid mass with the sour taste of lactic acid. That's called curd. So during the curdling process, you see that there is formation of lactic acid. Being an acid, it is going to lower the pH of milk. So during the course of the curdling process, we see that the pH of the milk slowly comes down, isn't it? So which graph is clearly representing that? Yes, perfect, perfect. Many of you have answered it correctly. Very good. Graph A, because the pH value is declining over the course of time, which means acid is building up. So slowly the pH will come down during the curdling process. Okay, great. Let's move on to the next question. I think that question was very much clear to everyone. Okay, the next question is, while diluting an acid, water is slowly added to acid with constant stirring. Is that assertion true? Is that assertion true? While diluting an acid, water is slowly added to acid with constant stirring. Is the assertion statement true there? Yes, everyone. See, when you dilute acid and base, you have studied that when you cause any kind of dilution into acid, it is going to ionize the acids, right, or the bases. So especially when it comes to strong acids like HCl, HNO3, etc., when you dilute it, the process is highly exothermic. So you have to do dilution in such a way that first we have to take a large amount of water and then add acid drop by drop along with continuous stirring, so that each drop of acid will have less number of acid molecules. They get ionized, they release heat, and with the continuous stirring, you are redistributing the heat over the entire water. So you can control the ionization and the heat released so that no accidents will happen. But what if you do the other way? You take the entire acid and then you pour water into it. What will happen? All together, the acid molecules is going to ionize all at once, releasing a large amount of energy, which causes acid splashes, breaking off the glass vessels, etc. So the assertion statement is actually false. The problem with assertion is that it says water is slowly added to acid. No, you should add acid to water drop by drop with constant stirring. So that's false. The reason says the process of dissolving an acid in water is highly exothermic reaction. That is indeed true. The process of dissolving an acid in water is a highly exothermic reaction. Acids and bases dilutions are always exothermic because it releases a large amount of energy. So the reason is correct, but the assertion is false. Is that clear to everyone? Okay, great. The next question. Methyl orange and phenolphthalein are synthetic indicators which are used to test acids and bases. Is that true? Methyl orange and phenolphthalein, they are synthetic indicators. They are indicators which indicates the presence of an acid or a base. So that statement in assertion is true. The reason given, indicators are special chemicals which changes their color to indicate the presence of an acid or a base. That is also true, and that's why these indicators are used to test the presence of acids or bases. Some of them are indicating the acids and bases presence by change in color. Some of them are changing their odor or the smell. So there are olfactory indicators also. So these two statements are correct, and they are very much dependent, because whatever reason statement is given is very well explaining the assertion reason why methyl orange and phenolphthalein is used as an acid base indicator. So we can go ahead with option A. Yes, great guys. Everyone has given the correct answer. Excellent. Okay, now let's move on to another question. I would say a very important question. This is a high priority question. The flow chart shows an important compound used in chemistry. There is something written as X, and then there is chlorine, and then the combination is showing white powder having strong smell of chlorine. White powder having strong smell of chlorine. That is none other than bleaching powder, isn't it? So immediately we can fill all the things here, because I know that chlorine is going to combine with the calcium hydroxide, which is slaked lime. Dry slaked lime will combine with chlorine to form calcium oxychloride or bleaching powder. And that calcium oxychloride is combining with H2SO4 to form something plus chlorine plus water. You know that this is a calcium salt, and if calcium salt is reacting with sulfuric acid, definitely a sulfate salt will be created. So what will be the salt formed here? The salt formed here will be calcium sulfate. So calcium sulfate plus chlorine plus water will be the product of this reaction. So they asked what is X, Y, and Z. So we identified each of them. What is X? X is slaked lime, dry slaked lime. What is Y? Y is bleaching powder, CaOCl2. Then we have Z, which is CaSO4. So all the substances are identified. Now, write the chemical equations between X and chlorine. X and chlorine means CaOH twice plus chlorine. That's going to give you what? CaOCl2 plus H2O. Bleaching powder plus H2O. Then white powder Y and H2SO4. White powder Y and H2SO4, it's already given here. CaOCl2 plus H2SO4 gives CaSO4 plus chlorine plus water. That will be the reaction. Is this clear? And what happens if Y is exposed to air for a long time? So what will happen when bleaching powder is exposed to air? Bleaching powder will liberate chlorine gas. That's why we get the pungent smell of the chlorine gas. And list any two important uses of Y. So bleaching powder is used for, yes, as the name indicates, it's used for bleaching. And also it is a very good disinfectant, especially for bulk water bodies like a pool, etc. are cleansed by using bleaching powder. Okay? Yes, so that's a very important question. Bleaching powder preparation and properties. Okay, let's go to the next question. State the name and chemical formula of the hydrated salt that changes from blue to white when it is heated. A hydrated salt that changes from blue to white when it is heated. You have studied this, right? Copper sulfate pentahydrate, CuSO4.5H2O, commercially known as blue vitriol, isn't it? This particular salt on heating will become copper sulfate plus 5H2O. The color of copper sulfate pentahydrate is blue, whereas anhydrous copper sulfate, what is anhydrous copper sulfate without water of crystallization? That's called as anhydrous copper sulfate. So that is going to form CuSO4 plus 5H2O. The water of crystallization will vaporize on heating. Is this clear? So the name of the salt is, when you write the chemical name, you do have to write the name with the crystallization. So it is copper sulfate pentahydrate. Clear, right? And it forms copper sulfate anhydrous. Anhydrous copper sulfate means copper sulfate without water of crystallization. Okay, great. Any doubts? So I hope this is also clear. So by now you might have realized the transition that we took from chemical equations and then going through acids, bases and salts. So we are actually covering the entire thing. So by the time carbon anhydrous compounds is over, you will not have any trouble in chemistry. The following table lists the pH values of some substances. We have hydrochloric acid pH 1, milk 6, pure water 7, then baking soda 9, sodium hydroxide 14. Question is, what would happen to the pH of an acid and a base when each one is diluted, pure distilled water is added to it? Very, very important question. On dilution, the strength of an acid and a base decreases. What is the reason? You have studied that. There is a very, very important statement in the textbook. On dilution, the number of H plus ions in acid and OH minus ions in base per unit volume decreases, right? When you are diluting, you are adding more water. So what will happen is the number of ions per unit volume. Unit volume means in every liter of water. Say for example, I have a beaker which is having 1 liter of 1 molar HCl. What is the meaning of that? It means 1 mole of H plus ions is there in 1 liter. Into this, if I am adding 1 more liter of water, the total volume will become 2 liters. But still the number of H plus is the same, right? 1 mole of H plus is there in 2 liters now. Effectively, I have only 0.5 mole of H plus per every liter. Did you understand the math? This is how the dilution affects the H plus ion concentration. Clear? So for an acid, when you dilute, what will happen? The pH will keep on increasing, and for a base, the pH will keep on decreasing. Yes, pH of an acid will increase and the pH of the base will decrease. Okay. So someone is asking what is the mechanism of ethene formation from ethanol. See, that mechanism is a 12th standard topic. When we discuss about carbonyl compounds at that when that reaction comes, I will explain. Okay, so wait for that. Right. So the next one, we say that greater the pH than 7, more basic is the solution, whereas lesser the pH than 7, more acidic is the solution. Justify the above statement. See, you know that pH is a direct measure of which type of ion? Measure of H plus ion concentration. So, when it comes to a base, what happens, or when it comes to an acid, what happens is concentration of H plus ions is greater than that of OH minus ions. When it comes to a base, concentration of H plus ions is less than that of OH minus. That means OH minus is more. And then when they both are equal, then that's called as neutral. H plus is equal to OH minus. Is this clear? So this is how we judge or we measure the value of pH. So remember that pH is less than 7 means the H plus ion concentration is higher. So pH less than 7 means there is more H plus. pH more than 7 means there is lesser H plus. So this relationship you have to remember, because quite a few times this kind of questions have been asked. Like they give you the pH of various solutions and they ask you to arrange them based on the increasing order or decreasing order of H plus concentration. Is that clear? Yes, sure, you will get the PDF of these questions. Hope this question is clear to everyone. Okay, great. The next question. Can you apply the concepts I just explained and tell me the answer of this? The pH of 3 solutions is given in the table. Answer the questions that follow. Solution P, the pH is 1. Solution Q, the pH is 7. Solution R, the pH is 14. Which of these solutions could possibly react with zinc metal to produce hydrogen gas? What kind of metal is zinc? We learned that zinc is a amphoteric metal, isn't it? Amphoteric metal means what? It can react with acid as well as base. So being an amphoteric metal, it is going to react with acid as well as base. So tell me, P is having pH 1. What does that mean? This is an acid. This is 7. That means it's going to be neutral. And this is 14. That means it's going to be base. So zinc will be able to react with both P as well as R because it's amphoteric, right? So I want you to remember and recollect the reactions of zinc metal when it behaves like an amphoteric metal. For example, Zn plus HCl. If it reacts with HCl, it forms ZnCl2 plus H2. In this reaction, the acid is HCl and zinc is behaving like a base. Whereas if zinc is reacting with NaOH, what will happen? It will form Na2ZnO2 plus H2. In this reaction, NaOH is the base, but zinc is behaving as an acid. So these two reactions confirms the amphoteric behavior of zinc. They may ask the same question when a question related to aluminium comes, because aluminium also behaves the same way. If aluminium reacts with HCl, it forms aluminium chloride plus H2, and if aluminium reacts with NaOH, it will form NaAlO2, sodium aluminate plus hydrogen. And guys, remember, this is the metal reacting with the acid and the base. If it is metallic oxide, the product will be water instead of hydrogen. Hope it is clear. Yes. Which of these solutions could be formed by the reaction of a metal oxide with water? Which of these solutions could be formed by the reaction of metal oxide with water? The hint is there. Metal oxides, they are basic. So when they react with water, what will happen? They will form bases. And what is the pH of the base? More than 7. So here the pH, the solution that is probably going to form will be R. Clear? And one more question. Which of these solutions could be the raw material for the industrial manufacture of chlorine? Guys, do you remember how do we make chlorine? What is the method called? The industrial manufacture of chlorine. Do you guys remember chlor-alkali process? Chlor-alkali process. We take NaCl and H2O and then pass electricity through it. Correct? So when you pass electricity through it, you will get NaOH plus H2 plus Cl2. This is the chlor-alkali process. So this is one of the industrial manufacturing of chlorine. So here they ask which of these solutions could be the raw material for the industrial manufacture of chlorine. That should be NaCl solution. And what is NaCl solution's pH? Its pH will be neutral because NaCl is a strong acid, strong base combination. So Q should be the raw material used for the preparation of chlorine. Is that clear to everyone? Any doubts in that? Okay, perfect. Let's go to the next question. 4 students recorded the following observations. Identify the correct observation. We have an electrolyte given and the observation is given. Okay, dilute HCl, bulb does not glow. Glucose, bulb glows. Dilute NaOH, bulb glows. Alcohol, bulb glows. So, correct observation. Which is the correct observation? See, dilute HCl will definitely ionize. Correct? So, the bulb has to glow. Glucose is not going to ionize because glucose is a covalent compound. Dilute NaOH will definitely ionize. Alcohol will not ionize. So which is the correct observation? Dilute NaOH, bulb glows will be the correct observation, right? A is not correct. You see, I can see some of you are answering A. Dilute HCl, bulb does not glow. That is wrong. Dilute HCl will make the bulb glow because dilute HCl can have ions. Clear? It will release ions. So the correct option will be C. Is that clear to all? Yes. Okay, great. Yes, very good, Jagjit. Very good, Devang. A white powder is used by doctors to support fractured bonds. Write the name and chemical formula of the powder. Yes. What is the powder? It is Plaster of Paris, isn't it? It is Plaster of Paris. That is the common name of the powder, which is used for treating fractures. So, Plaster of Paris. What is the chemical formula? CaSO4 dot half H2O. What is the chemical name? It is calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Yes. How is it prepared? How is it prepared? You know that calcium sulfate hemihydrate is obtained by heating gypsum, correct? By heating gypsum. Heating gypsum. What is the reaction of heating gypsum? Calcium sulfate dihydrate CaSO4.2H2O on heating will form CaSO4.half H2O plus 1.5 molecules of H2O. Guys, remember this heating has to be limited up to 373 Kelvin. If you heat it above 373 Kelvin, what will happen is all the water will go out, which will leave only calcium sulfate. That is called anhydrous calcium sulfate or dead burnt plaster. Clear? Dead burnt plaster. So, please do remember to mention the temperature here, 373 Kelvin. This is how you make plaster of Paris from gypsum. Now, the C part of the question says, when this white powder is mixed with water, a hard solid mass is obtained. Write a balanced chemical equation for the change. So what is going to happen? The reverse reaction. When you take plaster of Paris and you add 1.5 molecules of water to it, it will harden again to form what? Gypsum. That will be the chemical reaction. Clear? Any doubts in that? Okay, let's move on to the next one. Salt A, commonly used in bakery products, on heating gets converted into another salt B, which itself is used for the removal of hardness of water, and a gas C is evolved. The gas C, when passed through lime water, turns it milky. Identify A, B, and C. Guys, look, the hint is there in the question itself. Salt A, commonly used in bakery products, on heating gets converted into another salt, which itself is used for removal of hardness of water. So we understood salt A has to be baking soda, NaHCO3. This on heating, you know that it will form Na2CO3, which is soda ash, which can be recrystallized to get washing soda, that is used for removal of hardness of water. Plus, what else do you get? H2O plus carbon dioxide. So this is salt A, and this is salt B, and it is giving a gas also. So carbon dioxide is the gas. And then they said the gas C, when passed through lime water, turns it milky. So that confirms that the gas is carbon dioxide, because carbon dioxide will turn lime water milky. You guys remember the lime water test? That is another important topic from this part. What is lime water test? If you pass carbon dioxide into lime water, which is an aqueous solution of calcium hydroxide, it forms CaCO3 plus H2O. CaCO3, being not soluble in water, will render this solution a milky white coloration. And then what happens? What is the next? If you pass excess of carbon dioxide into this solution, what will happen, or what can happen? It will form the bicarbonate of calcium. Bicarbonate of calcium is soluble in water, so it will leave the solution clear. So this can be a potential question. They will ask you, why does lime water turns milky when you pass carbon dioxide? Answer is due to the formation of calcium carbonate. Why does the milky white colored solution turns transparent on passing excess carbon dioxide? Due to the formation of calcium bicarbonate. Is it clear? Yes. Okay, great. Next. Devang is saying, yes, A is baking soda, correct? You can write the names also if you want there. Baking soda. Then this is soda ash. And C is carbon dioxide. Perfect. See, refine your answers, okay, when you're writing. Don't just limit the answers. Write the answers as refined as possible, so that, you know, the person who evaluates your paper feel that, yes, this guy knows something. So that create that impression, okay? A student performs some activities on two substances M and N and record the observations in a table as shown below. The activity: cut with a knife. The substance M forms small pieces, substance N forms small pieces. Beaten with a hammer, the shape changes for substance M, but substance N changes to powder. That gives us a clear explanation. See, you know the main difference between metals and non-metals, right? So that is basically what is asked here. Striken with a metal rod, it makes a sound in substance M, it changes into a powder in substance N. So that clearly explains M is a metal, N is a non-metal, because metals are sonorous. Metals shapes changes, they are malleable, they are ductile, isn't it? But in case of non-metals, they are brittle, they will break into pieces, or they will change into powdered forms because they are amorphous in nature. Which option classifies the substance into metals and non-metals? So substance M is metal while substance N is non-metal. I hope the physical properties based classification is very clear to everyone. It's a very basic fundamental question. I wouldn't say it's a very important, but a very fundamental question which involves the physical properties of metals and non-metals. Okay, is it clear, guys? Shall we go to the next question? Right. The process of purifying the impure metal is called, so we are almost done with chemical equations and acids, bases and salts. All the areas are covered. Now we have now we have the next two chapters coming up, which is metals and non-metals and carbon ions compounds. Okay, so I will try to do it as fast as possible so that you can quickly revise it after this session. So also be confident in chemistry. So by the time biology and physics sessions are over, you will be 100% ready for the board exam. It will be a piece of cake for you. Trust me, follow the instructions promptly and do solve these kind of worksheets and do solve the question papers now instead of taking the textbook and reading the theory again and again. Okay? Right. Electrolytic refining. Guys, it's a sure question. Electrolytic refining of metals. So in this, the question says you have to select the anode, cathode and electrolyte combination. Very basic question, very fundamental question. It's asked many times. I would say it's a very important FAQ question. So in electrolytic refining, you know that it is done for purifying the metal, right? The metal that you get after conversion from the metal oxide. So that will have a lot of impurities. So what do? You will purify it by electrolysis. And in that electrolysis, the conditions are this. The anode must be the metal to be purified. The impure metal is taken as anode. Then a pure piece of metal is taken as cathode, and a salt solution of the metal to be purified is taken as the electrolyte. That is a combination. So tell me which option in these four options is correctly describing it. Anode should be impure metal, so that will rule out these two options. So among A and B, then cathode is pure metal, and electrolyte is not salt of any metal. It should be the salt of metal M. That is important. So one example is in case of refining of copper. That is what you learned in textbook. Refining of copper. Everyone should learn the diagram also. Electrolytic refining of copper. The apparatus is very important. In that, what do we take as anode? Anode should be impure copper. Then we have cathode, which is a pure strip of copper. Then we have the electrolyte. Usually we take aqueous copper sulfate. That's a combination. Clear? That is the electrolytic refining of copper. If it is zinc, impure zinc is anode, pure zinc is cathode, and electrolyte is zinc sulfate. Clear? Any doubts in that? No. So let's move on to the next. Cinnabar is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide and the gas X is given out. Mercuric oxide is then reduced into mercury on further heating and a gas Y is released. Identify the two gases. See, you know the process of extraction of mercury. In that, we have cinnabar, the ore of mercury. First, it is roasted. Correct? What is roasting? Sulfide ores are heated in the presence of oxygen. So on roasting, you will get HgO plus SO2. And the next step is, after you get the metal oxide, you know, for low reactive metals, you don't need a reducing agent. Yeah? Why you don't need a reducing agent? Because already they are low reactive metals. So if their oxides are formed, those oxides are not going to be stable, because these elements will not have much affinity for oxygen. So simply by prolonging the heating, they will undergo self-reduction to form Hg plus O2. So they asked, cinnabar is first converted into mercuric oxide and a gas X. So who is the gas X here? This is going to be gas X. And mercuric oxide is then reduced into mercury on further heating and a gas Y is released. Who is the gas Y? The gas Y is O2. That's a very important question, I would say. you know, from extraction of metals, definitely one of the extractions will be asked. So you guys remember that for highly reactive metals, we can't go with the typical reduction method because reducing agents will not have as much affinity as those metals. For example, if you plan to do a reduction method for extracting sodium, you know, it's not possible because in order to reduce the oxide of sodium, you need someone who is having more affinity for oxygen than sodium. Yeah, so we don't have such cases. So that's the reason why for highly reactive metals we go with the electrolytic process of their molten ores. They are directly reduced by electrolysis, isn't it? And then for moderately reacting metals, we have two options. We can either go with the carbonate ores and do calcination and then followed by reduction and then refining, or you can go ahead with the sulfide ores and then do reduction and then go ahead with the refining. And for low reactive metals, mostly the sulfide ores, and we can do self-reduction. Clear? So that entire flow chart about the extraction of metals is very, very important. Is it clear? Right. A student dropped pieces of potassium and silver in beakers containing water. The image below shows the reaction. So we have potassium plus water, we have silver plus water. What are the products formed in each beaker? See, you know that potassium is a fairly reactive element. So if you dip potassium in water, definitely it is going to form the hydroxide of it and hydrogen. So the reaction that happens in the beaker will be potassium hydroxide and hydrogen. And silver is dipped in water. You know that silver is a very less reactive element. So when you dip it in water, there will be no reaction as it is a very least reactive element. So out of 4 options, which one will be correct? Yes, option D says beaker 1 has KOH and H2, beaker 2 no reaction takes place. Is it clear? All alkali metals are like this. Not only potassium, you put sodium in water, you get sodium hydroxide. You put lithium in water, you get lithium hydroxide. Clear? Right. Yes. Good, good. Soya, Fatima, Prithvi, Kirtana, Jagjit. Very good, very good. The next question. Metals react with water to form a metal hydroxide or metal oxide and hydrogen gas. Is that assertion statement true? Metal react with water to form metal hydroxide or metal oxide and hydrogen gas. See, I already explained this regarding metal plus water. For example, if you consider metals like calcium plus water is going to give you calcium hydroxide plus hydrogen. But if you go ahead with metals like zinc and all, it will form oxide plus hydrogen. So some of them form hydroxides, some of them form oxides. Clear? Depending on which metal you are taking. Highly reactive metals forms hydroxides, and moderately reacting kind of categories forms metal oxide. So that assertion statement is correct. Yes, the assertion is true. Assertion is false. Why is it false, Shruti? You have the examples. No, you have studied the reactions of metals with water. Some of them reacts with hot water, some of them reacts with cold water, some of them reacts with steam. Yes, so depending on the metal, the product may change. Alkali metals and highly reactive ones will form hydroxides, but aluminum, zinc, iron, they all form oxides. So the reason given is sodium metal reacts with cold water and forms sodium hydroxide and hydrogen. Iron reacts with steam to form iron oxide and hydrogen. That is also correct because we have seen that sodium reacts with cold water pretty much violently because sodium is a highly reactive metal. So NaOH plus H2 is formed. Whereas in case of iron, when it reacts with steam, you're going to see Fe3O4 plus H2. right? Fe3O4 plus H2. So it's oxide in case of iron, and it's hydroxide in case of sodium. So that very well explain that in the assertion some of the metals are forming hydroxide, some of the metals are forming oxides. So both are dependent statements, and we can select A as the correct choice. The reason is very well explaining the or supporting the assertion statement. Is it clear, guys? Yes. Okay. Now the next one. Hydrogen gas is not evolved when a metal reacts with nitric acid. Is that statement true? Hydrogen gas is not evolved when a metal reacts with nitric acid. That is very much true. Why? Because imagine if you have a metal M and that reacts with nitric acid, what we expect is it should form metal nitrate plus hydrogen. But the problem is, nitric acid, apart from being an acid, it is a strong oxidizing agent. It will oxidize this H2 into H2O. So we don't see hydrogen gas coming up except in case of two elements, which are the magnesium and manganese. In these two cases, hydrogen is released. So except in case of these two metals, you never see hydrogen liberated from nitric acid metal reaction. So assertion is true. And the reason says nitric acid is a strong oxidizing agent, and it oxidizes the hydrogen produced to water and itself gets reduced into any of the nitrogen oxides. That is true. And that is indeed the reason why hydrogen is not liberated, because being an oxidizing agent, it oxidizes hydrogen into water. Yes, very good, very good. Yes, excellent. See, I really appreciate all those who are attending this session. Now, if you are thoroughly following this session, I'm telling you, this will have a huge impact on your chemistry scores. Okay, the next question. Water soluble bases are called alkalis. That is a correct statement, right? Alkalis are those bases which are soluble in water. Sodium oxide and potassium oxide dissolve in water to produce alkalis. Sodium oxide and potassium oxide, they dissolve in water to produce alkalis. That is also correct. So we can say that they both are correct and they are dependent statements. Water soluble bases. For example, what is the base formed by sodium oxide reacting with water? Sodium oxide is Na2O. It reacts with water to form what? NaOH. And this NaOH is soluble in water. It is soluble in water. That's why it is an alkali. Same is the case of potassium. K2O plus H2O is going to give you KOH. KOH is also soluble in water. And these soluble bases are called as alkalis. So the reason is very much supporting the assertion statement. So the option is A. Okay, great. The next question. An element E combines with O2 to form an oxide E2O, which is a good conductor of electricity. Write the formula of the compound formed when it combines with chlorine. Very important question, guys. This kind of question is a probable question going to come in this year's board exam. An element E combines with oxygen to form an oxide E2O, which is a good conductor of electricity. The hint says it's a good conductor of electricity, so this is going to be an ionic compound. So if it is an ionic compound, we can split the ions. E2O will be formed by E plus and O2 minus. Correct? These are the ions. So from this we understand that the valency of the element is +1. And they are asking what is the formula of the compound when it combines with chlorine. That's very easy. E plus is the ion of the element. Chlorine will be always Cl minus. So if they combine, what will be the formula? ECl. ECl. Write the formula of the compound formed by when it combines with chlorine. They didn't ask you to name the elements. They didn't ask you to name the element. So just use the symbol E itself. They asked an element E combines with oxygen to form an oxide, E2O, which is a good conductor of electricity, and write the formula of the compound formed when it combines with chlorine. So stick with the same symbol, E. So it will be ECl. Clear? Is that clear to everyone? No. See, E means there is only one of it. ECl means this is analogous to compounds like LiCl, NaCl, KCl, these kind of compounds. Understood? Yes. The point is that that element has a valency of +1. That's all. Okay. Answer the following. Write the electron dot structures for sodium, oxygen, and magnesium. Yes, yet another important area, electron dot structures or the Lewis structures. Sodium. Sodium is an element with an atomic number 11. So 281 is the electronic configuration. So sodium has one valence electron. So we can draw the Lewis symbol of sodium as Na with one dot. Oxygen is atomic number 8. 2,6 is the electronic configuration. So it has total 6 valence electrons. And then magnesium is there, which is 2,8,2, and that will have 2 valence electrons. So Mg. This is the Lewis structures of each of those elements, showing their respective valence electrons. Show the formation of Na2O and MgO by the transfer of electrons. See, Na2O, this compound is formed by the combination of 2 sodium ions with 1 oxygen. So how do we show it by the electron dot structure? So let's take one of the sodium ion and another sodium ion, and it is combining with oxygen. So oxygen already has 6 valence electrons. So 1 electron from this sodium go here, 1 electron from this sodium go here. So that will make 1 sodium ion to have a positive charge. There are 2 such sodium ions, and oxygen will now have an octet in its outermost shell with the 2 negative charge. Right? This is how the formation of Na2O takes place. Is this clear? Yes. Now, MgO also they asked. MgO is also very easy. MgO is 1 magnesium and 1 oxygen. Mg has 2 valence electrons. Oxygen has total 6 valence electrons. So with 1 Mg and 1 O, it's sufficient. So 2 electrons will be transferred. Mg will now have 2 positive charge. Oxygen will now have 2 negative charge. So balancing the charges, we get MgO as the formula. Clear? What are the ions present in these compounds? That's very easy. In Na2O, how do we split the ions? We show the ions. It is Na plus ion and O2 minus ion. And in MgO, which are the ions? 2 ions, Mg2 plus and O2 minus. This is how you represent the ions in both the compounds. Okay? Clear, everyone? Cations and anions. Yes. What are the ions present in these compounds? We don't just write cations and anions. You have to write which cation and which anion. Okay. Right. Clear for all? Right. Stainless steel is a very useful material in our life. In stainless steel, iron is mixed with. What do we mix with iron? We have nickel and chromium, right? See, alloys, that is also another important section. You guys know that alloys are homogeneous mixtures of 2 or more elements, isn't it? So we have a lot of alloys, like you have studied for brass, which is copper and zinc. Then we have bronze, which is copper and tin. Then we have solder, which is lead and tin. So all these examples which is mentioned in the textbook are very important. So in stainless steel, we are going to mix it with nickel and chromium, which increases the shine of the element. Clear? Okay, here comes another important question. What are amphoteric oxides? Choose the amphoteric oxides among the following. I already told you what are amphoteric oxides. Oxides that can react with both acids as well as bases. That's called as amphoteric oxides. And we have to pick the amphoteric oxides from these examples. Okay, let's see. How about Na2O? What kind of oxide is it? Na2O is a basic oxide. ZNO is a amphoteric oxide. Al2O3 is also amphoteric. Then we have carbon dioxide. Carbon dioxide is a non-metallic oxide, so it's going to be acidic. And H2O is neutral. Clear, right? Amphoteric means either acidic or basic. Neutral means neither acidic nor basic. Hope it is clear. Okay, great. Let's move on to the next one. Which of the following are not ionic compounds? Look, the general say is this: metal and non-metal. Usually it will be ionic. Non-metal will be covalent. So applying that, we can see KCl. KCl is between metal and non-metal, so it has to be ionic. Then we have HCl. Hydrogen is a non-metallic element, so this is going to be combining with chlorine, which is another non-metallic, so it is also, it is a covalent compound. Then carbon tetrachloride will also be covalent in nature. Then NaCl is metal plus non-metal, so it's going to be ionic. So which of them are not ionic? Not ionic is HCl and CCl4, that is 2 and 3. 2 and 3. Clear? See, HCl is a polar covalent compound. It is able to ionize in water. It is a polar covalent compound. You will study in 11th standard what is polar covalent compound and how is it different from ionic compound. In 11th standard, there is a chapter called chemical bonding and molecular structure. At that time, you will study in detail about what is the difference between this polar covalent, non-polar, ionic specifically. So in this case, you remember the general rule: metal non-metal combination ionic, non-metal covalent. Clear? Right. The next question: on undergoing complete combustion. So we have moved on to carbon ionized compounds, guys. So that's the last unit we have to discuss. So metals and non-metals, then acids, bases, chemical equations. Almost 85 to 90% of the topics I have discussed. Now we have the next one. On undergoing complete combustion, in an adequate supply of oxygen, an organic compound produces only carbon dioxide and water vapor as the products. Based on this information, which of the following homologous series could this compound belong to? Alkanes, alcohols, aldehydes. See, they say on undergoing complete combustion in an adequate supply of oxygen. That is very clear. Adequate supply of oxygen means oxygen is not going to be a limiting factor. You know that saturated hydrocarbons on combustion with adequate supply of oxygen will release carbon dioxide, water and energy. Unsaturated hydrocarbons will burn incompletely with a sooty yellow colored flame. But there is one point to remember: even saturated will produce smoke if oxygen is a limiting factor, if oxygen is not present adequately. But that condition is ruled out here because they said adequate supply of oxygen is there. So they are asking in which case you get carbon dioxide, water vapor as the product. Okay, what do you think is the answer? Alkanes, alcohols, aldehydes. See, in alkanes, there is only carbon-carbon single bond. In alcohols also there is carbon-carbon single bond only, right? The general alcohols are having carbon-carbon single bonds. Aldehydes are also having carbon-carbon single bonds. All of them are saturated. Hence, all of them are going to give you carbon dioxide, water vapor, and heat as the products. Clear? It's not only alkanes. Remember that we have alkanes, alcohols, and aldehydes. Some of you are saying B, P and Q only because you think that in aldehydes there is double bond. No, guys. Double bond is between C and O. This is an aldehyde. Here, is there any carbon-carbon double bond? No. Do you understand that? So all of them are going to give you carbon dioxide and water as the products. Okay. Aldehydes are unsaturated because of double bond with oxygen. No, that's a wrong understanding. Let me clarify this. Saturated and unsaturated. Saturated compound is where carbon-carbon single bond is there. Unsaturated is where at least a carbon-carbon double bond is there. You have studied only half. You studied if double bond or triple bond is there, it is unsaturated. No, between who is very important. Carbon-carbon double bond or carbon-carbon triple bond. If that is there, then it is unsaturated. Otherwise, it's not unsaturated. Is it clear? In aldehydes, the double bond is not between carbon and carbon. It is between carbon and oxygen. Are you guys clear now? Right. Next, a compound with which of the following functional group is most likely to cause the decomposition of baking soda to produce carbon dioxide? Baking soda to produce carbon dioxide. Come on, guys. We studied this reaction. I think in 2 slides we already discussed about this. Metal bicarbonate will react only with acids. Which is the functional group which is an acid in this? Among the 4 options, which is the functional group which is an acid? The only functional group is this one, COOH. COOH is called as carboxylic acid. Carboxylic acid can react with metal bicarbonate to release carbon dioxide. Isn't it? Yes. So, can you guys recognize all these functional groups again? What is OH? This is alcohol. What is CHO? This is aldehyde. What is C double bond O? It is ketone. And COOH is carboxylic acid. Is it clear? CH3, CH2, CH2, COOH. Can you tell me what is the name of this compound and tell me is it saturated or unsaturated? The name and tell me if it is saturated or unsaturated. Yes, Chris, can you tell me? Can you post your answer in the comment box? This has 1, 2, 3, 4 carbons. So it's called as butanoic acid. And here carbon-carbon bonds are all single bonds. So it is going to be a saturated compound. Clear? Yes. Very good. Very good. It is butanoic acid. Let's move on to the next question. 1 mole of ethene and 1 mole of ethine are separately to completely undergo addition reaction to form respective saturated compound. Which of the following will be different for the 2 reactions? Okay, to understand that question, let me write a equation there, okay, for getting a clarity. 1 mole of ethene and 1 mole of ethine are separately to completely undergo addition reaction. See, let's take ethene. What is ethene, guys? CH2 double bond CH2, that is ethene. So if I have to do addition reaction of ethene, I just need to add 1 mole of hydrogen so that I get ethane. So 1 mole of ethene react with 1 mole of hydrogen to form 1 mole of ethane. Yeah, that is the first case. And they said 1 mole of ethyne are also undergoing reaction. So let me take ethyne. What is ethyne? CH triple bond CH. This is ethyne. This will undergo addition with 1 mole of hydrogen to form 1 mole of CH2 double bond CH2. You guys understand that? Because there is a triple bond here. So first one of the bond is broken, 1 mole of hydrogen is added, and you get a double bond. And then what should happen? This should add 1 more hydrogen to get 1 CH3 CH3. Correct? So altogether for ethane to become ethane, how many hydrogen is required? 2 mole of hydrogen is required. But ethene to ethane require only 1 mole of hydrogen. You understood that? It's a very, very easy question, I would say, but a little bit you have to think, because every addition reaction means what? If you have a multiple bond and into that bond you are adding hydrogen. So if you have a double bond, only 1 hydrogen will add. But if you have a triple bond, if you want to make it single bond, what should happen? See guys, look at this. It can be understood simply by looking at this picture. See, I want to convert this into saturated. So I need to first break this bond. So what will happen? Still a double bond is left. I added 1 hydrogen successfully. Now I need to break this bond. Then only it will become what? Fully saturated. So if I need to break 1 triple bond, I need 2 moles of hydrogen. If I need to break only 1 double bond, I need only 1 mole of hydrogen. Okay? Yeah, of course you have to use nickel, palladium or platinum. Those are the catalysts. So this is a very, very interesting question. Yes, indeed, it is an interesting question, and it's basically a simple application question. You just, if you simply by heart the reaction of addition reaction and go to exam, that is where the problem is. If you understand what is hydrogenation, you have to explain it to yourself about what you understood about that reaction. See, it's like this. When you learn addition reaction, you have to visualize. In addition reaction, an unsaturated hydrocarbon is adding hydrogen. So during addition, what is happening? The multiple bond is broken and hydrogen atoms are added. So you learned the reaction of ethene becoming ethane. So tomorrow if they ask you what will happen if propene is added hydrogen, it will become propane. And if they ask you a triple bond, you need to remember that addition should happen twice. Then only it will become single bond. Got it? So I hope the idea is clear to everyone. So which of the following will be different for 2 reactions? The number of mole of saturated compound formed. Look at this. In both the reactions, how many mole of ethane we are getting? Only 1 mole. So number of mole of saturated compound formed is not different. Number of moles of hydrogen consumed, that is different only, right? Look here, 1 H2, here it is 2 H2. That means for ethene to become ethane, it's 1 H2. Ethine to become ethane, that's 2 H2. Got it? Yes, yes. Okay, so what is the right choice? Yes, what is different is they asked. So it will be only Q. Clear, right? See, these are the questions where I wouldn't say difficult, but there are some questions which will snatch that 1 mark from you and leave you with the 99 out of 100. So be careful with these kind of questions. It's not tough. It's not at all a tough question. It's a very simple question, but logical thinking need to be there in order to answer these kind of questions. I hope you understand what I'm saying, right? Okay. The structural formula of 4 organic compounds are shown below. Choose the correct option. So they have given 4 statements there. Okay, let's try to identify each of them. Okay, that's our first task. Who is this, or what is this? The first compound. What is this compound? Joel, I didn't get the question clearly. You asked what would be the definition, because we were told that unsaturated hydrocarbons add hydrogen in the presence of catalyst as palladium or nickel to give saturated hydrocarbons. Yeah, that's true. Unsaturated hydrocarbons means you can have alkene or alkyne. So if you take alkene, you have to break only one bond to add one hydrogen, right? And if you take an alkyne, alkyne is triple bond. So if you want to break a triple bond, you need to add 2 moles of hydrogen. Yes. So this is ethane, right? Now, what is the second compound? The second compound is CH3 COH. That is ethanoic acid. Then we have CH3 CH3. This is ethane. Then we have CH3 CH2OH. That is ethanol. That is ethanol. Yes. So choose the correct option. 1 and 2 are saturated hydrocarbons. 1 is not saturated, so that is gone. 3 and 4 are unsaturated hydrocarbons. See, 3 is saturated, so that is also gone. Addition of hydrogen in presence of catalyst changes 1 to 3. 1 to 3. Who is 3? Yeah, 1 to 3. Addition of hydrogen in presence of catalyst changes 1 to 3. That is true, right? Because ethene will convert into ethane if you add hydrogen. So that statement is correct. Now we will read the next statement also and see what is the error in that. Addition of potassium permanganate changes 2 to 4. What is 2? 2 is ethanoic acid and 4 is ethanol. It's the reverse, isn't it? KMNO4 or potassium permanganate or K2Cr2O7 potassium dichromate, they both are oxidizing agents. They both are strong oxidizing agents. So these oxidizing agents are going to oxidize alcohols into carboxylic acid, not carboxylic acid into alcohol. So they said 2 to 4. 2 to 4 means acid into alcohol. That is impossible, right? That is impossible. So you must understand that alcohols can be oxidized into carboxylic acid, and in your textbook the example given is ethanol is oxidized to ethanoic acid. So don't just learn that, generalize it and explain it to yourself that if you take an alcohol and add oxidizing agent, it will become the corresponding acid. So tomorrow in the exam they might be asking, if you take butanol and add KMNO4, what will you get? It is not there in the textbook. That should not be the answer. You should write butanol is going to get oxidized into butanoic acid, like ethanol gets oxidized into ethanoic acid. Am I clear? Yes. Okay. So the answer here is C. Now, given are the structural formula of 4 compounds. Which 2 of these compounds are more likely to have similar properties? A sure question. You can take this question. This is a very, very important question which is having high probability to come in the board exam. The one who has similar properties will be the one who has same functional group, right? You studied that, homologous series. Homologous series of compounds are those compounds in which the number of carbon atoms may be different, but the functional group is same. And functional group is the one which decides the chemical properties. Correct? Functional group is the one which decides the chemical property. So this has to be answered based on that. First compound is a ketone. You see C double bond O. Second compound is an alcohol. Third compound is a carboxylic acid. Fourth compound is an alcohol. So which 2 compounds have same functional group? This and this. So Q and S will share same chemical properties, because chemical properties are decided by the nature of the functional group. Clear? Any doubts in that? No. Great. So shall we move on to the next question? Oh yeah, before I move on to the next question, can I have the names of all these compounds? The first one is a ketone, right? It's a 3-carbon ketone. So it's going to be propanone. This first compound is propanone. Second compound is an alcohol, where alcohol functional group is in the second position, so it is called propan2-ol. And then third compound has 3 carbon atoms and it is a carboxylic acid, so I'm going to call this as propanoic acid. And the last compound is having 1 carbon and an alcohol group, so it is methanol. Got it? Those are the IUPAC names of the compounds given in that slide. Clear, right? Okay. Good. Now let's move on to the next question. Very, very important question. When you see that structure itself, you can understand. Devang, propanol and propan2-ol are different, okay? Look, what I wrote here as Q is propan2-ol. But you must remember that CH3, CH2, CH2OH, this is called as propanol. You see the difference? What difference do you see here? Here OH group is connected to the first carbon. Here OH group is connected to the second carbon. So that is a different compound. I would call them as isomers. Clear? They have the same formula but different structures. Hope it is clear? Okay, next question. A student studies that soap solution results in micelle formation, which helps to remove dirt. It has a unique orientation which helps in keeping the dirt out of the water as shown in the image. What helps the dirt to rinse away? How does soap helps in cleansing? That is a very important question. You guys know that soaps are long chain sodium or potassium salts of long chain carboxylic acid. For example, if I write here CH3, CH2, 14 times COONA, this is a real soap molecule. It's called sodium palmitate. That's a real soap molecule. So in this soap molecule, you can see there is a long chain of hydrocarbon here. This is completely non-polar, or we also call it as the non-ionic end of the soap, whereas this part is the ionic end of the soap. Ionic end of the soap can easily dissolve in water, whereas non-ionic ends cannot dissolve in water. Instead, it dissolves in oil or grease or dirt. So what happens is, the moment you put soap molecules into water, they are going to form an aggregation like this. This spherical aggregation is formed in such a way that the non-ionic end, what I am marking here are the non-ionic end. These non-ionic end will be towards the grease or the dirt, and the ionic end will be exposed towards water. So what happens? None of the part of the soap molecule is insoluble in water. Every part which is exposed towards water is soluble in water. So this forms something like an emulsion, and that emulsion helps in solubilizing the dirt or the grease. That's how soaps are able to cleanse the dirt or the grease or the oil. So the question is, what helps the dirt to rinse away? Suspension of the dirt in the micelles? Yes, that will be the right choice, because the dirt is suspended in the micelles and the micelles are soluble in water. A collection of water molecules in the center of the micelle? That's wrong. In the center of the micelle, who is there? Oil or grease will be trapped. Clear? Attraction between ionic end and dirt to remove it? That is also wrong. Dirt is attracted not towards the ionic end. Instead, it is attracted towards the non-ionic end. Mixing of soap molecules along with dirt to make it heavier? No, soap doesn't do that. They are not making the dirt heavier. Instead, they are making the dirt to get solubilized in the form of a micelle or a suspension. Clear? So A will be the right choice. A student studies that acetic acid is a saturated compound. The structure of the compound is shown below. Why is acetic acid classified as a saturated compound? Come on, who can answer? I already told you about what is saturated, what is unsaturated. At least those who had a misnotion about that is now clear, because acetic acid also has a double bond between carbon and oxygen. Are you seeing this? So can we call this as an unsaturated compound? No, we call it as a saturated compound because all the carbon-carbon bonds are single bonds. Is that clear, guys? Yes, because there is single bond between the carbon atoms. Yes. Okay, excellent. So that concept is clear to everyone. Great. The structure of a hydrocarbon is shown below. Study the structure and select the correct statements. Come on, which structure is given here? 1, 2, 3, 4, 5. 5 carbons are there, all single bonds. So you know that this is pentane, correct? Pentane. The statements. Molecular formula of the compound is C5H12. Is that true? Is that true? Alkanes, all of them have a general formula CnH2n plus 2. So if you put 5, it should be C5H2 into 5, 10 plus 2 is 12. C5H12. So that statement is correct. The next homologue of C5H12 is C4H8. Wrong. The next homologue of C5H12 should be C6, isn't it? H14. It should not be C4H8. Why? The previous homologue will be C4H10. C4H8 means what formula is it fitting? CnH2n. So that is wrong. It is an isomer of pentane. Very much true. Pentane has got 3 isomers. What are they? Normal pentane, isopentane, neopentane. Are you all confident in drawing the isomers of pentane, butane, and hexane? Yes. It has 14 single covalent bonds. Is that so? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 covalent bonds are there. So the number of covalent bonds listed is wrong. So the question was study the structure and select the correct statements. The correct statements are only 1 and 3. The option is going to be B. So this question is clear to everyone? Okay. Next, the substance used for oxidation of ethanol and the compound formed on oxidation of ethanol is. I already told you about this oxidation of ethanol. How do we do the oxidation? Ethanol is CH3, CH2OH. If you oxidize, you have different oxidizing agents, alkaline KMNO4 or acidified potassium dichromate. This will give you CH3COOH. So the substance or used for oxidation is alkaline KMNO4 or acidified potassium dichromate. The oxidized compound is CH3COOH. So I think option 1 itself is correct. Alkaline KMNO4, CH3COOH. Show neopentane. Yes, sure. About the isomers part I was discussing in the last slide. For N-pentane, the first isomer is CH3, CH2, 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 CH3. This is normal pentane, the straight chain of 5 carbons. Then we have CH3, CH, CH3, CH2, CH3. This is called isopentane, which is a common name, and the IUPAC name is 2-methyl butane. Then we have CH3, C, CH3, 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 which is called neopentane or 2,2-dimethyl propane. These are the three isomers of pentane. Or you can say, if they ask you to draw the isomers of C5H12, this is the structure. These are the three structures. So I hope neopentane structure is clear. CH3, C, CH3, CH3, CH3. Okay? Right. Following are the members of a homologous series. CH3OH, CH3, CH2OH, CH3, CH2, CH2OH. Guys, do you think the assertion is correct or wrong? I told you homologous series means compounds that have the same functional group. So in this case you can see OH, in this case you can see OH, in this case you can see OH. So all of them are alcohols, and we have CH3OH, CH3CH2OH, CH3CH2CH2OH. All of them are alcohols, so they belong to one series. Then the reason given is a series of compounds with the same functional group but differing by CH2 unit is called as a homologous series. That is also correct, and that is indeed the reason for that assertion why these guys are homologous series. So those who didn't get that, I'm repeating that point again, because I can see that some of the answers says it is not homologous series. So if you didn't understand that, I'm explaining again. Any set of compounds which have same functional group, look at this, in all these compounds the functional group is OH. So these three compounds have the same functional group. The difference between first compound and second compound is additional 1 CH2 is there. The difference between second compound and third compound is another additional 1 CH2 is there. So if adjacent members differ by 1 CH2 group or having the same functional group, they are called as homologous series. I hope it is clear now. And what will be the difference in the mass between homologous series? One CH2 group is having a mass of 12 plus 2, which is 14 units. So we can say that adjacent members in the homologous series will have a difference in the molecular mass of 14 units. Okay. Next, electronic configuration of carbon is 2,4, and it always forms covalent compounds by sharing electrons. Is that true? The electronic configuration of carbon is 2,4, and it always forms covalent compounds by sharing electrons. That is true, because carbon can neither lose electron nor gain electrons. Correct? So the assertion statement is correct. The forces of attraction between the molecules of these compounds are not strong. Covalent compounds, intermolecular force of attraction is pretty weak because they don't have any charges. So that is also correct. So here we have electronic configuration of carbon is 2,4, and it always forms covalent compounds by sharing electrons. That is true. The next statement is also true, but they are not dependent statements. Why carbon forms covalent compounds is another reason. What is the reason? If it loses 4 electrons, it requires so much energy. If it gains 4 electrons, its nucleus is not strong enough to hold on to those 10 electrons. So the answer has to be B. They are not dependent statements. Clear? Yes. Okay. Another case-based question. Okay. Look at this. White vinegar, sometimes called distilled or spirit vinegar, has been a mainstay in households worldwide for thousands of years. It's easy to understand why. This versatile liquid presents a treasure trove of uses for cleaning, gardening, and cooking. It even has medicinal applications too. A child wants to know whether vinegar used at home is organic or not. what would be the chemical name and formula of vinegar? What is the chemical name of vinegar? The chemical name of vinegar is ethanoic acid or acetic acid. And what is the formula of vinegar? It is CH3COOH, isn't it? CH3COOH is the formula of vinegar, because vinegar is basically 5 to 8% solution of acetic acid. So its formula is CH3COOH. Now, why is vinegar also known as glacial acetic acid? This is a very important question. You know that vinegar has a freezing point or a melting point of 290 Kelvin. So due to this very low freezing point, in winter it freezes and forms snowy flakes in the bottle of vinegar, which gives the appearance of a glacier. So that's why it is known as glacial acetic acid. Is it clear? That's a very, very important question. A teacher demonstrated the process of ester formation, and then an ester was treated with alkali NaOH. What is the name of this process and why has this name been given to it? Okay, you guys know that when you mix a carboxylic acid plus alcohol, for example, ethanol plus ethanoic acid, in presence of an acid catalyst and you heat it, you get CH3COO, CH2CH3 plus H2O. This is esterification reaction. But they are asking, on treatment of the ester with an alkali, what is the name of this process? See, that is our important reaction here. CH3COO, CH2CH3. This is an ester. When it is treated with NaOH, what are you going to get? You get CH3COONa plus CH3CH2OH. This is sodium salt of carboxylic acid, sodium salt of ethanoic acid. This is mainly used in the preparation of soap, and hence it is known as saponification, as it is used in the preparation of soap molecules. That's why it's called as saponification. Clear? Esterification is the process of making esters. The same esters, when you break down in the presence of sodium hydroxide or potassium hydroxide, you will get sodium salt of carboxylic acid or potassium salt of carboxylic acid, which is used in the preparation of soaps. Clear? Right. Can C17H35COOH plus NaOH be considered as saponification? See, basically that C17H35COH plus NaOH will also give you C17H35COONa. That is a soap molecule. But you know, that reaction is not how you make soaps. We make soaps from fats or lipids, plant derived fats or animal derived fats, depending on what kind of soap are you dealing with. So usually these fats will be taken and we will boil it in alkali. That's how you get the sodium salts of fatty acids. That is basically called soap. That reaction is named as saponification. Okay. A neutral compound A is formed by the reaction of an acid B, which is present in an ant's sting. Ant's sting, when you say that, it's very clear that it is formic acid, correct? And an alcohol C, which is used in the preparation of tincture of iodine. Tincture of iodine is made by dissolving iodine in ethanol. It is having good antiseptic properties, right? Identify the compounds B and C. That is the question. So, a neutral compound A is formed by the reaction of acid B and alcohol C. So, acid B is present in and sting. And sting acid is methanoic acid, which is reacting with the C, which is ethanol, because it's used in the preparation of tincture of iodine, they say. So, how do we make a product in this? HCOOH plus C2H5OH will give you what? HCOO, CH2, CH3 plus H2O. This compound is called as ethyl methanoate. That's very easy. You just look into the alcohol. Which alcohol is it? Ethanol. Which acid is this? Methanoic acid. So ethanol plus methanoic acid is ethyl methanoate. Suppose if it is ethanol and ethanoic acid, it is ethyl ethanoate. Suppose if it is ethanol and propanoic acid, it is ethyl propanoate. Are you getting that idea how we name the esters? This part of the ester is from alcohol. This part of the ester is from acid. Clear, guys? Okay. Next. Manasi wrote the names of 4 compounds as the first members of their respective homologous series. She wrote methanol, 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 methanoic acid. Answer the following question. Which name has she written incorrectly? Justify your answer. She wrote the members of the first member of each homologous series. Methanol. Methanol is correct because the first alcohol is CH3OH. Methanol is correct because the first aldehyde is formaldehyde or methanol. Methanol is wrong. There is no ketone with the name methanol because to form a ketone, you need minimum how many carbon? You need 3 carbons. CH3COCH3. Propanol is the first member of the ketone family. You know why? Because ketone is C double bond O, right? The moment I put a hydrogen here, it will become aldehyde. So I can't put hydrogen on the left or the right. So in order to get a ketone, I need to have minimum 3. Then methanoic acid does exist. It is HCOOH. That is also correct. So which name has she written incorrectly? Justify your answer. So the name which she has written incorrectly is methanol. The reason is you cannot have a ketone without 3 carbons minimum. Clear? Any doubts? What name should she have what name should she have written instead? I already told you she should have written propanol. Clear, right? So the first member of the homologous series of ketone is propanol. Soaps and detergents are cleansing agents. How do you differentiate between soap and detergent on the basis of their chemical constitution? What is soap? Soap is sodium or potassium salts of long chain carboxylic acids, whereas detergents are ammonium or sulfonate salts of long chain hydrocarbons or carboxylic acids, isn't it? That is the main difference chemically. Draw structure of a soap molecule showing hydrophilic and hydrophobic end. That I already showed you. You can take any example for that. You can take palmitic acid, sodium palmitate or sodium stearate or any example. CH3, CH2, 14 times COONA. This you can take. In this part is the non-ionic end and this part is the ionic end. Clear? Non-ionic is what is called as hydrophobic. Ionic is what is called as hydrophilic. Okay? Explain why detergents are better cleansing agents than soaps in hard water. Very important question. You know, in hard water, the problem is soaps will react with the ions present in hard water like calcium and magnesium, and they will form calcium salts and magnesium salts, which will combine and become a heavier mass, and it will settle down as a precipitate called scum, right? So due to the formation of scum, the micelle formation will not happen in case of soaps in hard water. But detergents don't have that issue. Detergents will not react with calcium or magnesium ions. As a result, detergents are good cleansing agents in soft water as well as hard water. So they can ask you questions regarding this, like, you know, they give you 2 test tubes and how do you test that, which is hard water. So you add soap into both, and the one which has more lather will be soft water in with soap, and one which doesn't have more lather will be hard water. Like that, multiple type of questions are possible, but the concept need to be very clear. Soaps will get affected based on the hardness, but detergents do not get affected based on the hardness. Clear? Prasad has a saturated alcohol X of chemical formula C4H9OH. Write the chemical formula of a member Y that comes two places after X in the homologous series and state by how much will its molecular mass differ from that of X. See, what is the formula given there? C4H9OH. Right? C4H9OH. So that means it is an alcohol. The question is, write the chemical formula of a member Y that comes two places after X in the homologous series. Two places after X means, I told you in homologous series, what is the difference between the adjacent members? One CH2 group. So if I add one CH2 here, the next member will be C5H11OH, correct? The next member will be C6H13OH. So after two positions means you are looking at this molecule. So its molecular formula or chemical formula will be this. And what is the difference in the molecular mass? See, to this it is CH2, to this it is CH2. So total mass difference will be two CH2 groups. What is the mass of one CH2? 14 units. So 2 CH2 means 2 into 14 will be 28 units. Is that clear? Very simple question, but a conceptual question. Next, how do the chemical properties of X compare with those of Y? Give reason for your answer. What is the answer? How do the chemical properties of X compare with those of Y? See, X and Y have same functional group, correct? X and Y have same functional group. So what is the advantage? Therefore, they will have same properties, correct? Their properties are going to be same. So that's how you justify your answer. And write the chemical formula of the product Z formed by heating Y with acidified potassium dichromate, and write the general formula of for compounds in the homologous series that Z belongs to. See, write the chemical formula of the product Z formed by heating Y. So what is Y? They said Y is a member that comes after two steps. So Y will be C6H13OH. So I can write like this. C6H13OH means CH3, CH2, 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 CH2OH. This is C6H13OH. If I treat this with potassium dichromate, K2Cr2O7, what will happen? What will happen? Oxidation will happen. So you get CH3, CH2, 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 total 6 carbon atoms, right? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and the 6th carbon atom will become COOH. So it will become a carboxylic acid. Is that clear? So it will become an acid. So this molecule is hexanol, and it will get oxidized into hexanoic acid. Got the idea? So one is an alcohol and the other one is a carboxylic acid. Any doubts? Right. Which of the following is not a straight chain hydrocarbon? Yes. What do you mean by straight chain hydrocarbon? A hydrocarbon in which all the carbon atoms are connected at a stretch. For example, in the first compound, you can see that carbon atoms are connected at a stretch. You have total 1, 2, 3, 4, 5, 6 carbon atoms at a stretch. Then in the next compound also you have carbon atoms, 6 of them at a stretch. In the next compound also it is at a stretch. At a stretch means, it need not be straight, okay? It should be continuous, that's all. But in the next compound, you see what is the problem? Here, this is a longer chain. This is a longer chain, but this is a branch. So, you are not getting it at a stretch. So, the answer is D. It is not a straight chain. Okay? See, some of you have a notion that straight chain compounds are having the shape which is straight. No. Even if the shape is like a snake also, it doesn't matter. You need to understand that at a stretch means the carbon, straight chain means the carbon should be connected at a stretch. It should be continuous. That's all. Clear? Right. Yeah. This compound, the last compound is called as 2-methyl pentane. And the first 3 compounds are normal hexane. So they are isomers of hexane. Yes. That's correct. Okay. Next question. Which of the following is the correct representation of electron dot structure of nitrogen? See, you guys know that nitrogen's atomic number is 7. Electronic configuration is 2, 5. So nitrogen has total 5 electrons. So it will have to share how many electrons? 3 electrons. So with the nitrogen atom, the sharing would be somewhat like this. Correct? The sharing would be somewhat like this. 3 pairs of electrons are shared and you will have a triple bond between 2 nitrogen atoms. So which is the correct representation here? Option D looks correct. 3 pairs of electrons are shared. I hope it is clear to you. 2 electrons are unshared, but 3 are shared in between. This is unshared. Clear for all? All the 4 options are clear, right? The Lewis symbols. Out of that, D is only correct. Okay. What would be the products formed when ethanol is heated with excess concentrated sulfuric acid? Very important reaction. I am writing the reaction. Please remember this. Ethanol is CH3CH2OH. If you heat it with concentrated H2SO4 at a temperature of 443 Kelvin, it will undergo dehydration to form CH2CH2 plus H2O. CH2CH2 is called as ethene. Ethene. So, when ethanol is heated, it will form ethene plus water. And second reaction is, they are asking, what will happen if ethanol is treated with a sodium? So, CH3CH2OH, when treated with the sodium, will form CH3CH2ONA plus H2. Clear? Plus H2. Sodium ethoxide. That is the name of this compound. Guys, don't get confused between sodium ethoxide and sodium ethanoate, okay? Sodium ethanoate is CH3COONA. This is called sodium ethanoate. Whereas CH3CH2ONA is called as sodium ethoxide. So don't forget that, okay? Right. Support your answer with the balanced equation. So these are the balanced equations. So hope those 2 reactions are also clear. Okay. In that, one more reaction I want to mention before we stop is the photochemical chlorination. For example, you remember when methane is treated with chlorine in presence of light, you get CH3Cl plus HCl. This is called substitution reaction because halogen atom comes and substitutes the hydrogen. Clear for all? So with this, we have discussed most important topics from the chemistry section. So an overall idea about all the areas where you need to focus and all the areas you need to revise now is obtained from this particular session. So I hope you all have understood each and every question I discussed. And tomorrow and day after tomorrow, last one is not balanced. Yeah, sure. You can write the balanced equation. So 2CH3CH2OH, 2Na, 2CH3CH2ONA plus H2. Okay. So tomorrow and day after tomorrow, there will be respective subject classes. Physics and biology is now left, and then the day after that there will be a question paper discussion. So make sure that in these remaining days of preparation you are doing focused revision. Okay, whatever the subject teachers are explaining, those areas you have to focus, and then look into the recurring patterns based on the previous year's question sets. You will see that there is always an area, where questions are frequently asked. In physics, what all diagrams you have to remember, which all formulas are important, which all graphs are important. In biology, which all definitions, which all diagrams are frequently asked, which all labelings are important. All these things can be understood if you just skim through the past papers of the CBSE board exam. So I believe you all will stick to those plans and do a focused revision in these days. And if you have any doubts, we are there to support you. The support classes are going on. In morning, there is 8 to 2 sessions in every center. So those who want to come for extra practice, you can come to the center and clear all your doubts. So doing PYQ is enough. See, I would say if you have done pretty good revision for the chapters and the concepts and the theory, then yes, doing PYQs is advisable at this time instead of reading the theory again. I think I have one more doubt here. Ester is also known as ethyl ethanoate and ethyl acetate. Yes, ethyl ethanoate is same as ethyl acetate. They both are same. Acetic acid is the common name of ethanoic acid. So ethyl ethanoate or ethyl acetate, they both are same. Okay guys, so I think that's it. I'm not going to take more time. It's sharp. It's close to 8 o'clock now. So we have finished discussing all the chapters in chemistry. So I believe you are thorough with all the questions we did today. Go through the topics once again. If you do it today itself, it will be really good. Or wake up early morning tomorrow and go through all the 4 chemistry chapters once again. And then that's it. You will be fully confident to take up the board exam. So I hope everyone will stick to that. So with this, I think we can conclude our session. We'll see you in another video. Bye guys.